Hey guys, I opened a new series for formulae and simultaneous equations. And first, that's the right time if you're struggling with formula substitution, rearrangements, how to derive the formula, and probably how to solve simultaneous equations. That's the right time to start doing that. Okay, I'll show you a really cool, fast, and short way how to rearrange the formula using sort of like working like with the Lego blocks. Okay, that's pretty the same, just drag and drop, and this method works pretty fast. Even much more students struggling with SAT found this method is quite efficient and useful. Alright, so let's get started. The first is about formula substitution. So you need to be able to use formula in the proper way. So what does mean formula substitution? It means that instead of variables in the formula, actually to figure out another variable, you just need to plug the values. And that's the most common, and that's, however, the easiest part. Okay, let's go. So first of all, we define the formula as an equation which connects two more variables. Okay, so for example, formula for linear dependency for a specific line works like y equals 2x plus 1. That's also formula, but it gives you an idea what you need to do with x if this is sort of an input, okay, in order to get your output y. So the formula works the same as if you have an input in in a black box. For example, you've got an input and you also need to have the output. Let's say that's the box and you have an input right there. So that's going to be an input, and so black box basically handle the input and derive the output. So that's as any black box. Why I'm calling that black box, because you don't know what inside. So for example, if you use iPhone, you barely know how it works each component of that. So as well as you open the laptop, the same story. Okay, so that's why you don't know what's inside, but the machine tells you, okay, so you've got an input, let's say 2, somehow rearrange and you'll get an output. That's how any formula works. In this case, if we consider just linear formula y equals 2x plus 1, so instead of black box, you have white box. It's really transparent for you what the machine does. So you just take the value of 2 as input, you multiply by 2, so you double it, and on top of that you add 1. That's how this pretty simple formula works. Okay, but let's have an idea about what, because in real life you've got lots of formulas. So for engineering, for chemistry, for biology scientists, so it depends on the science. For example, let's take physics. Probably those who were passing GCSE physics will be much more interested in that. For example, let's take the pressure. Okay, so we know the pressure is directly proportional to the temperature. So the greater the temperature, the greater the pressure. So let's assume you have something like enclosed can. So you put it on fire. Okay, that's the fire, and you increase the temperature. What will happen if you have the lid on top of that? So the lid tends to just shift and goes off, right? So that's normally when you put a can with water, with liquid on a gas stove and you turn on a fire. So for some reason, the water becomes boiling, okay? And in this case, you definitely feel the pressure, okay? So right now, that's sort of proportional dependency, but how exactly it will tell you a specific rule for that. So P times the volume, if volume is not changing, so V is some given variable, equals to, let's say, number of moles RT. That's the right formula for in physics, okay? If we consider V as the given volume, let's say 1 meter cube, so instead of R we use 8.31 just constants. Instead of number of moles we can use just 1 mole, and in this case we get P equals 8.31 T. So using that as the formula, you can calculate pressure for a given temperature in kelvins, okay? So that's how physical formula works. But also, you can find lots of formula in your math, in your applied math. For example, let's have a look at distance. So distance travel is basically speed times time, right? So that how it works. You use velocity or speed in meter per second, you multiply by seconds, and that's how you can get meters. So in the formula, very crucial stuff is to understand the units, because sometimes units can help you to properly rearrange. So finally, I mean, if you rearrange the formula and you want to check, you'll just have units. So in this case, we understand that seconds will be cancelled. In this case, you will have meters in the end as the units for distance, okay? That how it works. And units methods is going to be very useful when you're trying to rearrange the formula, okay? So for example, you want to express V, so you, for example, messed up and say instead of division d over time, so you wrote d times time, okay? Check out the units. So speed is going to be meter per second. So finally, you need to get meter per seconds. But let's have a look what do you have right now. So you have distance in meters, you multiply by seconds, and so in this case you have meters times seconds instead of division. So that's going to be sort of a hint, and instead of multiplication you need to divide so that to keep track of the right units. So instead of multiplication you'll definitely use a proper division, okay? So that's why method of units will give you a powerful tool to check. I've told you it before, so I'm telling you right now as well. Okay, how basically to maybe substitute some values in the formula? What are actually the main steps? Write down the formula, that's the first obvious step. So you need to write the formula. For example, pressure is equal to 8.31 T. Temperature. State the values of their known variables. Okay, let's say temperature is going to be 100 kelvins. Okay, substitute into the formula to form one variable equation. So you need to have with one variable on one side and with values on the right side. So in this case, you just simply wants to take that pressure is going to be 8.31 times 100. Pretty obvious stuff. And then solve the equation for unknown variable. So in this case, unknown is pressure, and you just here need to calculate. Basically, it's going to be 831 pascals. That's the right units for pressure. So in this pretty simple case, it's pretty obvious what you going to do. However, if you have more complicated case, so probably you have, say, how the height of the projectile motion is connected with time. So you know it's quadratic dependency from physics. So let's have a look there. So consider a projectile motion of a stone which is dropped vertically down from the cliff with a height h above. So h is a parameter above the sea level into the sea, okay? So here is the cliff. It's vertical, so that's the point where your stone is going to be dropped off. Oh, my bad. Okay, so that's the stone. Due to the gravity force, it will fall down, right? So instead of that, you use basically a projectile track of the falling body. It's completely vertical due to the gravity force. It falls down into the sea, okay? And here is the height actually above the sea level. So that's the initial height, or basically can be height at any level, depends on the time. So right now it started off when time is equal to 0, then falls down. Okay, let's see what we have. We have d meters, the total distance falling, so it's measured from there, from that point, so up to any point during the fall. So that's going to be a distance during the fall, okay? So we can set up this as the distance d. All right, so we set up d. And of course, d is going to be dependent on time. So it's given by the formula d equals gt squared over 2. So d is equal gt squared over t. And we can say that's the formula. So we use that as dependency between d and t. So let's have a look at g. So t is time of the fall in seconds, okay? It's measured in seconds. And g is the acceleration free fall. In this case, you might take g equals 10. All right, so what do you need to find? You need to find the distance, okay? You simply need to find the distance in this case, and we need to turn on calculators immediately. So g equals 10 meters per second squared is going to be an approximate value, because you know, guys, that g is actually, you have more precise value. G is about 9.81. But for this purpose, we can round up and say, okay, let it be 10. So instead of that more precise value, we'll use 10. So what are you going to do? You need to find a distance falling after 3 seconds. So from there, you just need to write according to instructions that we had on the previous page. So, and that's normally the case. You need to write the formula. Then you need to understand which variable is known and which is not. In your case, g equals to 10 and time equals to 3. So you need to figure out distance. Distance is already expressed, so you don't need to rearrange the formula, just simply need to plug in. All right, so you've got 10, you multiply by 3, time, which is squared, and divided by 2. So you can use calculator, but you can also cancel manually and say, okay, we've got 5 times 3 squared times 9. So the final answer is going to be 45 meters. Okay, let's have a look at the units, how they can be cancelled. So if we want to check that we got meters, however, for this problem, for the first question A, it's not necessarily, but I'll show you how it works with the units. So g is measured in meter per second squared, so you've got g on top. So in terms of units, you've got meter over second squared. So you multiply by time, which is seconds, and squared. So you multiply basically by seconds squared. So when you divide by 2, 2 doesn't have any units, so you're left with that one, okay? Finally, we need to arrive to meters as any distance measured in. Okay, what we're gonna do, we can cancel second squared and second squared right there. So we're finally left with meters. And this is right because we measured distance and we calculated that. All right, so question B, the time to the nearest 1/10 second taken for the stone to fall 150 meters. Let's have a look at B part. So in B part, you're actually given that we have a distance equals to 150 meters. All right, so what we're going to do in this case, we just simply need to plug in, instead of d, into formula 150 meters. But hold on, so you need to find the time. There are two approaches. So it's highly recommended so that you have a tendency first to express your unknown variables and then plug all the values, because you know why? It's going to be good practice for you guys. And the second reason is that for some questions you might be asked exactly to just express the variable. In the section dedicated to actually rearrangements, the formula, it's highly necessary skills that you need to have in your set, okay? So that's why I'm going to show you how to easily write time first and express as the subject. So basically, using the formula before plugging distance, you need to rearrange so that you can express the time. All right, so let's do this. What I'm going to do, instead of d, I'll see that this sort of proportion, right? Or basically, it's sort of fractional equation. So instead of d, I'll write d over 1 to make proper ratios on the left side. And what I know, so my variable is right there. That's time. It's a squared. So first I'm going to use and express t squared. So how I'm going to do this? I just use crisscross multiplication rearrangement. So for now, for those who are not sure how to do this, just watch the video dedicated to forms basically to solving fractional equations. I told there how to rearrange and fast track. So I just remind you quick what you need to do. You need to use crisscross multiplication, but instead of just carrying t squared to the bottom part, I'll use just only drop g down, okay? So I put 2 here, I'll put 2 here, and I'll get 2d on top. And in the bottom part, in denominator, I'll have g. And on the right side, I'll left with t squared, okay? But now I understand that t squared is going to be just, I need t finally, so I'll take in the square root immediately. And now I don't have any t squared on the right side. By the way, normally, you know, I need to take plus or minus, right? Because when you square up, both plus and minus will give us plus positive value, and I'll get the same answer, 2d over g. But time is positive, right? So in this case, you have also sort of restrictions for time. That's why you cannot take negative signs. So for this reason, time is going to be square root of 2d over g. And now you can freely use your calculator. You can plug 150 meters there. G also is going to be 10, and that's how it works, okay? So you get your time as a square root of 150 times 2 and over 10, okay? Then you start canceling like this. So 15 times 2 is 30, so you'll get square root of 30. And in this case, you'll use calculator because you need to give your final answer to the nearest 10 seconds. So 1/10 means 1 decimal place, okay? You round up to 1 decimal place. So what I've got 5.477 and so on, okay? So that's enough. Just cut off up to tens, it's right there, and round up because the next digit is going to be more or equal than 5, so in this case it's 7, so roughly it's going to be 5.5 seconds, okay? That's going to be the answer for part B. So guys, make sure you got it how to do. For next video as a revision, you can go through different problems. That's the basics actually, and everyone need to understand how it works and keep on track units. So it's very necessary and it's very useful tool to check your answer in the right way that you actually have. So you guys can check that meter over meter per second squared. Let's check quick. So what sort of units you have? Normally you need to have seconds in the end, but let's have a check. So you have square root of distance in meters over g is going to be meter per second, so meter per second squared. So meters cancel, second squared goes up according to the rule, and you have square root of second squared, so that means finally you'll get seconds. So in the end you'll get seconds, all right? And that's the right units for time. So hope you got it, and that was actually extra check for you guys for your right rearrangements. Okay, thank you. That was Daniel Dallas. Don't forget to subscribe and share this video and other videos that you saw to anyone who interested in maths and actually who had problems. That definitely works for you guys as more benefits will come up. All right, thank you and see you later.